Well, if you hated the LCD, you're going to hate today, because today we have to do the LCD. Now, solving rational equations. Solving rational what?
Equations.
What does that mean?
It's an equation.
Equations that are rational, right?
What is the word that I circled mean?
Equation that can be
When
solved.
there's an equal sign.
There's an equal sign. Every single other lesson, no equal signs. Anywhere. Well, there, but that's not an equation. That's just telling us to solve it. Okay, bad example. All right. These ones actually have something on the other side of the equal sign.
An answer, eh?
I think that's funny because it's called fraction busters. I think that's just somebody who was teaching it at some point calls it fraction busters, which is kind of cute. Reminds me of Ghostbusters a little bit. Anyways, so when you have an equation, that equal sign will follow you all the way to the very end, and you will get an answer like x equals 3 or x equals 1/2. So in this example right here, your ultimate goal is to find out what x equals, right? What does x equal such that when you multiply it by 2/3 and subtract 5/2 from it, you get a result of 7, right? That's what that one is asking technically. Now, this one right here, we could solve by adding 5/2 and then multiplying by the reciprocal. Do you remember that from like Algebra 1? Maybe, maybe not. Probably not. But I'm going to choose to solve this the same way we're going to have to solve these ones. Okay? And that is by, let me highlight the important part of the instructions. Okay. Now, I don't like where it says top only. But multiply every term by the LCD to eliminate the denominators. So the way we go about solving this is we make it into an we take it from an ugly equation and make it into an equation that does not have fractions in it that we can solve a lot more reasonably. Okay? So, if I were to look here, this is the same thing as 2x over 3, correct?
Yes.
Okay. Minus 5 over 2 equals, I'm going to call that 7 over 1. Are you okay with that?
Yeah.
What would my LCD be?
6. Yeah, he's right.
6?
Yes.
So what I'm going to do is I'm going to multiply, sorry, new pen. I'm going to multiply each of these by 6 over 1. Because my multiplication property of equality says that I can multiply an equation by a number as long as I multiply every stinking part of that equation by that number. And I will still maintain an equation that has true equality. So, what happens when I do that? Well, if this was a multiplication problem like we solved the other day, I know it's tiny right there, but couldn't I cancel the 6 and the 3? That would become a what?
2.
And so I have 2 times 2x, which is over, do I need to write the 1? No? Question?
Yeah, I'm sorry. Just where do you get the 6 1 from?
6 is your LCD. So you're multiplying every term by the LCD over 1. So you're multiplying every term on both sides by the LCD over 1. Okay, let's look at this multiplication problem right here. Now this is a minus sign. Let me bring that down. But what can cross cancel here? The 6 and the 2. That becomes a 1. That becomes a 3. So what do I have?
15. Negative.
15 over 1, which is just 15. And then I have my equal sign. And nothing cross cancels there, but 7 over 1 times 6 over 1 is? Now I have an equation that's much easier to solve, don't I?
Yeah, sure.
Add 15. 4x equals
57.
divide by 4. Does 57 divide by 4 nicely?
No.
Does it reduce?
No.
So my answer is just x equals 57 over 4.
You don't want it
Now.
in a mixed number?
What?
You don't want it in a mixed number?
No. After like 3rd grade, you don't use mixed numbers.
No, why did we even learn it?
I don't know.
Oh my god.
Part of the reason why I don't like mixed numbers is because in order to check your answer or do any calculations with it, you have to turn it back into an improper fraction anyways. So why not just leave it as an improper fraction that's reduced? Okay, so one thing we do have to be cautious about in these problems is we end up sometimes with things called extraneous solutions. Say that with me. Extraneous solutions. Okay? So here is what an extraneous solution is. Remember when we had to talk about excluded values?
Yeah.
What happens if the answer that I got is one of those excluded values?
Oh no.
That's what's called an extraneous solution. So if I look back at this original problem, what were my excluded values?
3 and 2. 0.
I didn't have any
Oh.
because there were no letters in the denominators, so I didn't have any extraneous solutions. Does that make sense? So I don't need to worry about my answer. If I look over here, I have some I have some excluded values. So for example, just from right off the bat, I can tell x cannot equal 5.
Or 3.
X cannot equal 3. And if I factor this one, I think this factors into x minus 5 and x minus 3. So does that give me any more that it can't be? No. So far, I can't have 3 or 5 as an answer.
Or 0.
0 can be an answer. Because 0 minus 5 isn't 0. 0 minus 3 isn't 0.
I'm thinking about the numerator. I'm sorry.
Gotcha. Numerator we don't worry about that. Okay. So, what is my LCD? If I look just at my denominators, I have x minus 5, I have x minus 3, and I have x minus 5, x minus 3. Which one's my LCD? My LCD has to have all of those denominators hidden in it, right? So that denominator is in there, that denominator is in there, and that denominator is in there. So once I have my LCD, what do? I multiply every term. Now it says on both sides. It's on both sides of the equal sign. You really don't need to worry about that. It's not saying multiply on the right and the left. It's saying multiply both terms on the left side of the equal sign and on the right side of the equal sign. So I maybe go a little bit overboard with showing my work on this just because it gets very, very confusing if you try and write this shorthand. So here's what I'm going to do. I'm going to write this original fraction, and then I'm going to write a blank line for my LCD that I'm multiplying it by. Does that make sense?
Yep.
And then I'm going to say equals x squared plus 2x minus 15 over x minus 5, x minus 3 times whatever the LCD is over 1. And then minus x plus 3 over x minus 3 times whatever the LCD is over 1, and I'm running out of paper there. So that might seem a little bit extra, but I promise it makes more sense as you go through it.
Extraneous.
Not extraneous, just extra. So do you see how this is the original problem? It's x over x minus 5 equals that guy minus that guy. And I'm just multiplying each term by what? X minus 5, x minus 3 over 1. X minus 5, x minus 3 over 1. X minus 5, x minus 3 over 1, running out of paper. So far, so good?
So far, so good.
Now, I'm going to take this one at a time. You ready?
Sure.
Covering up stuff.
Whoa.
Don't look there. Look here. Multiplying them wasn't too bad, was it? So if I multiply these, I make it into one giant fraction. And what cancels?
X minus 5.
So what am I left with? X parentheses x minus 3. What comes next?
Equals.
Equals.
Oh, wow.
Now let's look at this one. If I make it into the one giant fraction, what cancels?
X minus 5, X minus 3.
What am I left with?
X squared plus 2x minus 15.
Minus.
Oh my god.
If I do that right there, what cancels? Technically, these are in parentheses, right?
Yeah.
Yeah.
So what cancels?
X minus 3.
X minus 3, so I'm left with,
X plus 3 and X minus 5.
yep. So by multiplying everything by the LCD over 1, yeah, that's not a pretty equation, but I would take that any day over something with fractions, right?
Yeah.
So let's do what we can with this. X times x, that's x squared, minus 3x, equals x squared plus 2x minus 15. Now this is a little tricky. I see a minus sign, but I also see something that I need to multiply after that. So what does that mean? Yes, I have to FOIL, but I have to distribute this minus sign after I have FOILed. So this will give me x squared minus 5x plus 3x minus 15. Yeah? Right? X squared minus 5x plus 3x minus 15. So let's see. X squared plus 2x minus 15 minus x squared plus 5x
Oh.
minus 3x plus 15. Now, yes, I could have combined those like terms before distributing my negative. Doesn't matter really what order. But now I got a whole boatload of like terms that I got to combine, right? So x squared minus 3x equals, what have I got? Ooh, these x squareds cancel out, don't they?
Oh yeah.
2x plus 5x minus 3x. That's 7x minus 3x. That's 4x. Yeah? And look at negative 15 and positive 15 cancel out.
Whoa.
My life just got a lot easier there, didn't it? So it gets ugly for a couple steps, but then once you're able to combine those like terms, it gets super quick. What do you think I should do? I'm going to move the 4x. Why am I going to move that? Because when we have an x squared, we want to move everything to the same side as the x squared and then factor to solve it. What kind of factoring is this?
Extraneous?
Extraneous is not a type of factoring. This is just GCF, taking out what they have in common, right?
Yeah.
So I get what from here? I get x equals 0. And from here I get x equals 7. Were either of those two numbers excluded values?
No.
So both of those answers are valid. Now, let's say that instead of x equals 0 and x equals 7, let's say I got x equals 0 and x equals 5. What's the problem there?
5 is an LCD value.
5 is an excluded value. So guess what I do?
Cross it out.
I exclude that value, and my only answer is x equals 0. What if I got this?
And none of them.
So what's my answer if they're both excluded?
0?
Not after.
No solution.
No solution.
Can you just put NA or no?
NA, not applicable,
Yeah.
totally different.
Okay.
This is applicable because it's your grade. Right? Okay, so we don't have either of those situations, but that's what we would do in those situations. Does that make sense?
Sure.
It's a little messy, but as long as you get rid of the fractions in the first step, you can usually play around with the algebra pretty decently. Now, if my answers are x equals 0 and x equals 7, I technically could check these answers. I could plug in 0 here, 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 here. I feel like the genie in Aladdin, right? And I would get a true statement. And I could plug in 7 here, 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 and I would still get a true statement. That seems incredibly tedious to check, doesn't it? So we're saying the shortcut is just make sure that your answers aren't one of the excluded values and trust that you did the algebra correct.
Wait a second.
Okay? Yes.
What if you plug in the excluded values? What will happen?
The excluded values?
Like if you put 5 as x, what's gonna happen?
So I just told you that if you put in 0 or you put in 7, you would get a true statement, right?
Yeah.
If you plugged in 5, here, 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 you would have issues, etc. Because what's 5 minus 5?
0.
And anything over 0 is an impossible pizza situation. So that fraction is not even possible.
Okay.
Okay? So that's what would happen with an excluded value. Okay, turn the page. I'm going to skip that bottom part.
Yay. Right?
Now, at the bottom, I'm just going to address this really quick. If you are not confident of your algebra skills, and when I say algebra skills, I mean that part right there.
Yeah.
If you're not confident about that, check your answers. Plug them in and see if you get the right thing. If you are confident, just check the excluded values. Now, she shows how you check your answers for these examples. So, looking right here. I have fraction equals number plus fraction. Well, I need all of them to be fractions in order for me to do this, right? These two are like that. What are my excluded values?
3.
X cannot equal 3. Any others?
No.
No. What is my LCD?
X minus 3.
X minus 3. Everyone okay with that? So what am I going to do? I'm going to take the original problem, and I'm going to do this multiply by something equals 2 over 1 multiply by something plus 12 over x minus 3 multiply by something, and I'm going to end up going into the other space, but we'll adapt. What am I multiplying each of those by?
X minus 3.
Over 1, right? X minus 3 over 1 and x minus 3 over 1. Why do I think it's important to do the 1 thing?
So it's easier.
Because fractions, you like multiplying a fraction by a fraction better than a fraction by a number, usually. So let's see. If I look just at, I'm going to do my cover-up thing, just right here, and I make the one giant fraction, what cancels?
X minus 3.
And what am I left with?
4x.
Over 1, but now I don't need to write it. Yeah?
Yeah.
Equals. Let's look at the next one. What cancels?
None.
So I have 2 parentheses x minus 3. Plus, what cancels there when I make one giant fraction?
X minus 3.
So I have 12.
Yeah.
I'll take that equation. 4x equals 2x minus 6
Plus 12.
plus 12. So 4x equals 2x plus 6. I'm going to move the 2x. It gives me 2x equals 6.
3.
Yay, box my answer, I'm done, right?
No.
Why am I not done?
Because that's an excluded.
Crap, that was my excluded value, wasn't it? Which means I can't box it. I have to throw it away, which means my answer is what? No solution. Because if I try and plug 3 in to check it, I end up with these fractions that don't exist. Because they have denominators of 0. If I were to try and plug it in on my calculator, my calculator would start yelling at me. And you know how your calculator yells at you?
Error.
It says error.
Oh.
Okay? Questions there? Now, you know the difference between no solution and that. That is a solution. Right? It's a solution of 0. No solution means that even 0 doesn't work. There is no number that you can plug in for x into this equation and get a true statement. Okay? By the way, just to address this, because it drives me nuts, there are some people, I don't know if it's a cutesy thing and you're trying to be fancy, but there are some people that like to do this for their zeros. And I'll see this all over the place. 0, 0, 0. That's not a 0. I don't know what language you're talking in, but that's not a 0. Do you know what that means? It actually means that there is no solution, not even 0. Okay? So if you're using that as a 0, I'm going to start having to mark some things because you're using it incorrectly. Can you use that symbol for no solution? Sure. But you cannot use it for 0. Capiche?
Wait, so there's no solution, you can do that?
You can do this, yes, but if you do it for a 0, then I have to mark you off. Okay? All right. Now, the way you learned to solve equations like this a long time ago was a little bit different because you would have been given an equation in a slightly different form. This one is easier. It is fraction equals fraction. Do you see that?
Yeah.
Fraction equals fraction. Only if you have it in the form fraction equals fraction, you can use the shortcut of cross multiplying. Do you have to use the shortcut of cross multiplying? No. You can find the LCD and multiply everything by the LCD over 1. Totally fine, ends up doing the same thing. But if you notice that it's fraction equals fraction, you can skip the LCD step. So how does this cross multiplying work? Well, you multiply 2 of them together, 2 of them on the diagonal. Doesn't matter which diagonal you choose first. This would be x and then 2x plus 5. And you set it equal to the other diagonal. 1 times 11x plus 8.
Can you skip that step?
What do you mean, can you skip that step? Like, can you go straight to 2x squared plus 5x?
Yeah.
Can you not be that lazy?
I'm just asking.
Just show me your work. Now, I have an x squared, so I need to move everything to the same side as the x squared. So I'm going to subtract 11x. That gives me 2x squared minus 6x equals 8. I'm going to subtract 8. 2x squared minus 6x minus 8 equals 0. By the way, something I forgot to get at the beginning were my excluded values. This one would be negative 5 halves, and this one would be negative 8 elevenths. So hopefully I don't get something ugly like that. All right, what can I do here?
Factor.
Take out a...
2.
Is there going to be an answer here with the 2?
No.
So technically I can just drop it off. In other words, what I should have done instead of factoring out the 2 is divided by 2, because that's how it would go away. What does this factor into?
4. 1 and 4.
With the 4 is negative?
Yes.
So I have x plus 1 and...
Minus 4.
So I get an answer of x equals negative 1, not excluded, so it's good. And x equals 4, again, not excluded, so it's good. If you want to see the check for that, she actually does check those 2 numbers here, checking x equals 4 and checking x equals negative 1. Okay? So?
I have a question.
Yes?
So, you know how like you subtracted the 11x from like both sides of the equation and then the 8?
Uh-huh.
Could you do it like by subtracting the 5x?
Good question. Could you do it by subtracting the 5x? If you subtract the 5x, then you have to move the 2x squared over here, and what does that do to your a value?
It makes it,
Negative. You would have a negative 2x squared. You don't want to factor with a negative a value.
oh.
So you want to move everything to the side that'll keep x squared positive. Okay? All right.
Would it end up with the same answer?
Happy studying.
Happy studying.